Part 2, Year 10 and 11, which is equivalent to Cambridge IGCSE. Now, before diving into the theory related to electronic configuration, let's have a look at the syllabus for topic specifications. In IGCSE Chemistry, we will expand the knowledge related to electronic configuration concept by adding additional theory related to the shells. Moreover, we will also focus on ions in IGCSE Chemistry, not just neutral atoms. So, what do students need to know about electronic configuration in year 10 and 11? First, the idea of electronic configuration in terms of shells. But mainly this is for the first 20 elements from hydrogen to calcium. Also the capacity of each shell, which is the first shell 2 electrons, second shell 8 electrons, third shell 8 electrons, and so on. But did you know that this is a complete lie? The number of electrons that can fill to the shells is not 288. It's far more complicated than that. But that's beyond IGCSE and usually comes in AS A-level or IB AS A-level chemistry. So in short, IGCSE students only need 288 for the first 20 elements. Then, can you do this question before we move to the next theory section? What is the electronic configuration of aluminium? Here is the basic information about aluminium from the periodic table. Pause the video if you need additional time to think. The correct answer is option C. Aluminium has 13 electrons. So these 13 electrons will fill 3 shells. First shell 2 electrons, second shell 8 electrons, and third shell 3 electrons. If you do not remember the rule related to electronic configuration, let's quickly recap. The first shell of an atom can have maximum 2 electrons. The second shell and the third shells can have 8 electrons. Fourth shell actually can have much more than 8 electrons. When you want to figure out the electronic configuration of an atom, you must start with the first shell and fill the second, third, and fourth shells chronologically. For example, here is sodium, which has atomic number 11, which means sodium has 11 protons, and at the same time, sodium has 11 electrons. Now I need to arrange these 11 electrons according to our rule. Our rule is first shell can have 2 electrons maximum, second shell 8, and third shell 8. I need to put these electrons of sodium into the shells. So according to the rule, we must start with the first shell. If I put 2 electrons into the first shell, I have 9 electrons left. Second shell can have only 8 electrons, so I will completely fill the second shell, but still I have 1 more electron left, and that electron must go to the third shell. So what is the electronic configuration of sodium? It is 2, 8, and 1. Now let's talk about ions. What is an ion? To understand that, let's have a look at these two atoms. They both are atoms of lithium. In the neutral state, lithium has 3 electrons and 3 protons. As protons are positively charged and electrons are negatively charged, the 3 positive charges get neutralized by the 3 negative charges. Therefore, a neutral lithium atom has no overall charge. But what would happen if I remove 1 electron from the lithium atom? Then there will be an imbalance in the charges. There will be 3 positive charges, but there will be just 2 negative charges. As a result, this lithium atom acquires an overall positive charge. This is what we call an ion. An ion is obtained when an atom loses or gains electrons. Generally, ions gain or lose electrons to get a noble gas outer shell. So, what is a noble gas? A noble gas is a type of chemical element that is very unreactive because its outermost electron shell is full. So, if an atom has just the first shell completed, or both first and second shell completed, or first, second, and third shells completed, as shown over here, they are called noble gases. In the periodic table, first three noble gases are helium, neon, and argon. Now, you can easily locate them as all the noble gases are placed at the right corner of the table. There are few more noble gases, but we do not need to memorize them at this level. So let's move back to ions. What is an ion? Ions gain or lose electrons to get a noble gas outer shell. What does that even mean? For example, here is sodium. As you can see, sodium has three shells. Two of them are already bearing the maximum number of electrons. But the third shell, which could hold 8 electrons, only has 1 electron. Now, you might need to use your logic to figure out what sodium would do next. There are two options that sodium can use to reach a noble gas structure. Sodium either could gain 7 extra electrons to make the third shell filled with 8 electrons, or sodium could remove the single electron from the last shell, resulting a complete 8 electrons in the second shell. What might be the easiest way to reach the noble gas structure? I think removing 1 electron is much easier than trying to find out 7 more electrons. Therefore, sodium would remove the last electron of its third shell and reach the noble gas shell. This action makes sodium an ion. So, what charge does sodium obtain when it becomes an ion? Pay attention to the original neutral form of sodium. The nucleus has 11 protons, and there are 11 electrons in the shells. The positive charge of 11 protons has neutralized by 11 negative electrons. But not in this ion. In the ion, we have 10 electrons and we have 11 protons. So there will be one proton that cannot be neutralized. That makes sodium positive 1 charged ion. In the exam, there might be questions like this. For example, write the electronic configuration of sodium ion. As we already learned how sodium ion forms, I will use that module directly. How many electrons does sodium ion have? It has 10 electrons. So, we use our electronic configuration rule to fill the shells. The first shell gets 2 electrons, and the second shell gets 8 electrons, and we have already put 10 electrons, and that's all. So, the electronic configuration of sodium is 2, 8, which is actually equivalent to the electronic configuration of neon. To finalize the chapter, let's have a look at one of the Cambridge IGCSE past papers. So, this question was taken from 2025 May-June exam paper. In the question, it is asked, which particles have the electronic configuration 288? We have 4 options: an argon atom, an aluminium ion Al3+, a sodium ion sodium+, and a chloride ion Cl-. Now, let's start with the argon atom. To answer this question, you must use the provided periodic table in the exam paper. So, let's have a look at the argon atom. the atomic number of an argon atom is 18. The atomic number refers to the number of protons or the number of electrons. Therefore, argon must have 18 electrons. So, using that information, I can easily draw the argon atom into an atomic orbital structure. Argon, the first shell. Now, before moving to that, let's quickly recap the electronic configuration rule. The first shell must have 2 electrons. Second shell, actually it's not must have, first shell can have 2 electrons. Second shell can have 8 electrons, and the third shell can have 8 electrons. Fourth shell, it can have many more electrons, but you do not need to know the exact number. So using this rule, argon 18, how many electrons can it bear? First shell, 2 electrons. Second shell, 8 electrons. Now we have already put 10 electrons into 2 shells. Now, how many electrons left? 8 electrons left. That means the third shell can have 8 electrons, and we have 8 electrons. Will have 8 electrons in its orbital. So what is the electronic configuration of argon? Normally we write the electronic configuration chronologically from first shell to the last shell. First shell has 2 electrons, second shell has 8 electrons, and the third shell has 8 electrons, which actually matches the given question. Therefore, argon is an option. Now, for the question, I will discuss all the 4 options and finally reach to the answer. However, in the examination, you have to use strategy. What kind of strategy? Now, as argon is already an option, you should select answers with number 1, which means answer option 1, A, and answer option B. So, you just need to check option 3 and option 4 only. However, for now, I will check all of them. Let's have a look at aluminium. So this is not aluminium atom, this is aluminium ion, aluminium 3 plus ion. So, what does 3 plus mean? Now, in the previous part, I have discussed an atom gains a positive charge when it releases electrons. The positive charge comes from the number of protons that outnumbered the number of electrons in the nucleus. So, if there is 1 extra proton in the nucleus than the number of electrons, it gives it positive 1 charge. If there are 3 extra protons than the number of electrons in the shells, it gives a 3 plus charge. So, this aluminium 3 plus refers to the atom losing 3 electrons. Therefore, it gains a 3 plus charge. So, let's have a look at the way how to draw the aluminium 3 plus atom. I will first draw the aluminium neutral atom. Now, if I have a look at the periodic table, I can see the atomic number of aluminium is 13, which means in my diagram, I can start by mentioning aluminium 13. So the first shell will have 2 electrons. Second shell will have 8 electrons. I have already added 10 electrons into the shells, which means I will have 3 more electrons, which will move to the third shell. However, this is not what we need. What we need is aluminium 3 plus. As I mentioned before, the 3 plus refers to losing 3 electrons. So, as you can see, the last shell of aluminium has 3 electrons. So, we can easily remove these 3 electrons from the last shell. As a result, we get aluminium 3 plus. Now, what is the electronic configuration of aluminium 3 plus? First shell we have 2 electrons and the second shell we have 8 electrons. However, in the question, we have the electronic configuration 288. But in aluminium 3 plus, we have the electronic configuration 28. Therefore, the answer aluminium 3 plus is wrong. Now let's move on to the third option. It is sodium plus. Let's have a look at the periodic table for sodium's atomic number. Sodium's atomic number is 11, which means sodium has 11 protons and 11 electrons. First, I will start with the sodium's neutral atom, sodium 11. According to our rule, the first shell will have 2 electrons. Second shell can have 8 electrons and we have 9 electrons. Therefore, there won't be any problem. We can put 8 electrons into the second shell. We have one more electron left. So that electron moves to the third shell. However, this is not what we need. What we need, according to the question, is sodium plus. Sodium plus means sodium losing one electron from its shell. So as you can see, the last electron in the last shell can be easily removed. So let's remove this electron, and now we have sodium plus ion. So what is the electronic configuration of sodium plus? First shell has 2 electrons and the second shell has 8 electrons. Unfortunately, that's also not the answer that we want. We want electronic configuration 288, which leaves us with chloride ion. So you can already figure out the answer. The answer must be argon and chloride ion, as it is the only available option. Yet, right now, let's do the question and find out the answer ourselves. So, chlorine in the periodic table has 17 atomic number. So, I will write it down over here. Chlorine 17. Let's put them into the shells. So the first shell will have 2 electrons. Second shell will have 8 electrons. So we have already added 10 electrons. That means the third shell will get 7 electrons. As it can have 8 electrons maximum, we have no problem putting 7 electrons into the third shell. So this will be the electronic configuration of chlorine. However, this is not what we need. In the question, it's mentioned chloride ion, chlorine minus. The minus symbol is given from gaining an electron to the atom. So when the atom gains another extra electron, there will be an additional electron in the shells, which will outnumber the number of protons in the nucleus. As a result, it will give an electron negative charge to the atom. So, if chlorine receives one extra electron, it becomes chlorine minus, which we call chloride ion. Now, what is the electronic configuration of chloride ion? As you can see, the first shell has 2 electrons, second shell 8 electrons, third shell also 8 electrons. This is actually equal to the electronic configuration that we need. Therefore, our correct answer must be answer option B, argon and chloride ion. So, that concludes our theory related to electronic configuration for Cambridge IGCSE. We have already talked about atoms and ions. If you have this knowledge, you will be easily ready for the examination. So thank you for watching the video and see you in the next video.